Assalamu alaikum wa rahmatullahi wa barakatuh. Today we're going to be working on the electron configuration of aluminum atom. The first thing you have to note anytime you're given an electron configuration question is for you to first of all determine the number of electrons of the atom. Now, because aluminum is an atom, meaning it doesn't have a positive charge, it's not a cation, it doesn't have a negative charge, it is not an anion, we know that the number of protons and the number of electron is going to have the exact same number. It's going to be the exact same thing, right? Now, in order for us to now determine the number of protons, we're going to go back to our understanding of the periodic table. And for atoms, the atomic number is always going to equal the number of protons. And the atomic number of aluminum in the periodic table is 13, which makes the number of protons to be 13. Now, because aluminum is an atom, it is not an ion, so it's not cation and anion. That means it's going to have the exact same number. So that means the number of electrons for aluminum atom is also 13. Now that we've noticed that, alhamdulillah, thank God, we already got it. The next thing you have to do is that you're going to fill up this energy orbital diagram. And the first thing you have to do is you're going to fill from the lowest energy level or lowest energy orbital, which is 1s, up until the highest point where we've used all of our electrons up. So we're going to keep filling it up until all 13 electrons have been filled into the orbital. Now, each one of the orbitals, or which one of the boxes in this case, they're orbitals, but we're going to represent them as boxes. Each one of them can take a maximum of 2 electrons. So I just want you to keep that in mind as we go on to work. So we have 1 and then we have 2 electrons down out of 13, so we have 11 more. So we have 3, 4, we have 5, we've got 6, we've got 7. Interesting. Now, we've only used up 7, we still need to use up the rest of the 6. But before we go on to do that, I need to tell you guys something. Since this p orbital has 3 suborbitals, you've got the first orbital, the second orbital, the third orbital, hence 3 boxes. You're going to fill in each orbital before you pair electrons. And the reason is because electrons are negatively charged and you cannot put 2 electrons in an orbital without using up the other orbitals on the same energy level. It's going to cause something called energy destabilization. So negative electron cannot be put in the same orbital until you filled up the other orbitals, so that there is no destabilization, because of the electrons are negatively charged, and negatively charged electrons would repel each other. So when you filled each one of the 3, you can now pair them up. So you have um 8, you've got 9, you've got 10. Now we filled up 10, but we have 13. So we have to keep on filling. So you have 11, you've got 12, and then you've got 13. And we filled up all 13 of the electrons basically. So now we're going to write this down. We see that we have 1s2, we've got 2s2, we've got 2p6, because we have 3 orbitals in the p in the main p orbital, or 3 suborbitals. We've got 3s2, and then you have 3p1. So yeah, that is it. So that means the electron configuration for aluminum is going to be 1s2, 2s2, 2p6, 3s2, and then 3p1. And this is the answer to this. I wish you guys all the very best. Make sure you watch other election configuration videos on my channel. Assalamu alaikum wa rahmatullahi wa barakatuh.